laws of motion chapter. There what we said, the net force on a system, if it is 0, then the body is said to be in equilibrium. Even if a body is having uniform motion, net force 0, it is said to be in equilibrium. It's not that it must be at rest here. So what is the basic idea for translational equilibrium? So again, we have two types here, translational equilibrium. Then what we have is rotational equilibrium. And this, as we enter into the rotation mechanics chapter, no, there we discuss about this one. So for this, what happened? The net torque must be 0. What about translational equilibrium? The net force must be 0. So in general, if I say equilibrium, so what are the conditions? It must have translational equilibrium and rotational equilibrium. So combinedly, that we'll discuss in rotation mechanics. What we are discussing is problems related to translational equilibrium. Okay, fine. So this is the topic what we are going to work out here. So fine. Now, okay, after this, if you look at the how to define, so is there any types of equilibriums possible? I'll come back to this later on in the rotation equilibrium. So time being, you avoid it. So don't work out any numericals later. This is of no use at time being. That one. Again, the equilibrium, there are three types of equilibrium are possible. One, stable. So what are the features of a stable equilibrium? The word itself is a stable. So let me take an example. This is a ball. You take any block and you are going to displace the block here. So this is the mean position. So here the block is present. Now what happened? I'm going to displace it, the block, and we know that there'll be a force acting on the block. And what is that force? mg sine theta. And how is the displacement given in this direction? That mg sine theta will pull the block back to the mean position. So this is what I'll call. What do you mean by mean? Where the net force will be 0 here. Then again, if I similarly shift the block to the right, again the mg sine theta force will act like this. So look at this equilibrium. So how to identify? There's a one method what we use in physics. Check whether first is in equilibrium, as in equilibrium. For the equilibrium, what is the condition? The net force here, N equal to mg, or N minus mg equal to 0. So as I displace the block here from the mean position, the force will act opposite to displacement. Similarly here, if I displace the block, the mg sin theta will act opposite to displacement. So this particular system, what we can say, is a stable equilibrium. So what is the basic features of stable equilibrium? Net force must be 0. What are the features of that? Net force must be 0. I'll write it down. There's a thing. Then force will act, restoring force acts opposite to displacement. There's a one more, the opposite to displacement of the system, opposite to the block here, block, system, anything that will be. Next, third one, what put is like a potential G will be minimum. You look at this, definitely what happened, you compare to, there's a mean position, from mean position you have displaced it. So where it is having minimum potential G, this initial position. So when you shift the block like this, what will happen to gravitational potential? It will increase, no? Because height will increase. So where it is having minimum potential, it is having minimum potential at this particular point. This is the minimum, no? U is minimum here. So definitely what you calculate U will be greater than U minimum. So like this, we identify the system is in equilibrium or not. So there's a simplest method. So what is a mathematical way? I'm going to take help of the differentiation. So I'll be having a potential energy function. How to check minima maxima? You already come across that one. So take help of that mathematics and you're going to find out whether it's a equilibrium, stable, or any other this one. So this is about the first stable equilibrium. Then the unstable equilibrium. Just a small mathematical topic it is. Small mathematical topic. So now again, let me keep a block here. I'll give slight displacement, slight push. Then the block will, what makes it to look at the displacement, a slight push is given. Then it will move away from that mean position. No? Then similar or on the left hand side. So when I give a slight push to the block, mg sine theta will act here. And the push is given in this direction. So look at the force and the displacement, how they are in the direction of that. And this is the mean position. N equal to, here also, n minus mg equal to 0. So this is the mean. So about mean position, if you give slight displacement, the force will act in the direction of displacement. So that is a basic feature of unstable equilibrium. So what is the condition for unstable equilibrium again? For unstable equilibrium, see, stable, unstable. What is the basic feature? Net force should be 0. The first condition is the net force will be 0. Destabilizing force. Destabilizing force acts in the direction of displacement. And then what about the potential energy? Definitely you compare the mean position and destabilized position where the potential energy is maximum. Here, no, the potential energy here it is maximum. So therefore, what is the condition for unstable equilibrium? The potential energy of the system will be maximum. Okay, there's a basic feature one must remember: stable, unstable. Sometimes you get a situation where if they give potential energy equation, directly take help of this. If you have some sort of like if you displace, then you are able to predict, take help of this one. So either of approaches are needed. The second point, what I stressed is what the SHM chapter. The third point, what I'm stressing this one, no? So this is what mathematics, just it's a mathematics based questions. Hardly in physics, we use only in this chapter, I'll give several equations. I'll ask you stable, unstable equilibrium. But when it comes to the coming application part, no, the second point is what is going to help us a lot. So you have to work out some numericals related to this. Don't just confine yourself to this math based problems. Okay, after this, the third category is what? The neutral equilibrium. What is the neutral equilibrium? So if a body is kept on a I'll displace it. Again, it will retain. It is there's nothing. There's no any destabilizing force or restoring force. In whichever position you keep it, it will retain. The net force will be 0. That one. So this is the best example of a neutral equilibrium. You display the body and keep it here. Again, what happened to body? Will there's the position 1, there's the position 2. In the position 2 also happen the net force 0. In the position also net force 0. So this will be neutral equilibrium. Then, okay, after getting this much, so further we'll stress few more things. How to check a function minimum? I think you go back to this. What is the condition for minima? D square u by dx square should be greater than 0, no? And du by dx, I think we proceed like this. go back to a maximum minima idea, or already most of you know some mathematics, you are very good in maths also. Similarly, to check given function maxima, du by dx equals 0 and d square u by dx square is less than 0. Is it okay? No? So this is the mathematical approach is what we are going to develop here. So either stable, unstable, net force will be 0. Potential energy maximum, it's a unstable equilibrium. Potential energy minimum, stable equilibrium. Sir, what about the condition for this? D square u by dx square. Any condition for this? We can put it here. Will remain constant, no? Then there's a condition for neutral equilibrium. Okay, this is about the theoretical ideas. So we'll pick up few numericals, so that will be easy for us. First I'm coming with, read the question.
So d square u by dx square should be 0, right?
Constant, 0 also constant, no? Just some constant value. It should not be function of x or any other thing. Now come for question number. These are all maths based. Okay, you may find a very interesting all, but as far as physics is concerned, the application part may not help much this one. So I'll discuss initially in the end 1-2 problems. So that approach is what needed for. Okay, first we'll begin first this one. Okay, they're asking now, the particle is released at x equal -3, find the maximum kinetic energy of the particle during subsequent motion. Overall, it's a conservative force. One more thing, like if I get a potential energy, then how conservative force and the potential energy are related by this particular formula. Strictly, I'm making a rule in UX graph. In UX graph, if you take the slope, what when the negative of slope will be conservative force. Non-conservative force, potential energy, they are not related. Are you getting this one? So in UX graph, so if you take the slope, then what will happen there? The negative of that slope is what? Will be conservative force here. So what is U? U is a potential energy. So what is the meaning of this? Let me just, I'll take you back to this one. Suppose say here, let me take one function itself. Let's try to check this one. No. So this is the potential G and this is R. Okay, let me pick up points. So this is 1, this is 2, this is 3. And what is R? R is the distance between the atoms, and there's a potential G, interaction potential G of the atoms you can call. So potential G as a function of interacting distance is what I'm plotting. So these are the points which I'll consider 1. Okay, let's go for what is the slope at point 1? 0. So, and according to the formula, F conservative force, I'm writing in detail, F conservative force is what? Equal to minus du by dr, not non-conservative force, external force. They are not defined. The potential is defined only for conservative field. So you can write like this, potential energy is defined only for conservative field. So therefore, minus du by dr should be a conservative force, not some external or conservative plus non-conservative, nothing to do. Only it should be that one. Okay, now at 1, shall I say 1 is a equilibrium because net force is 0. Look at the slope. So what is the slope du at 1? What is the value of du by dr? It is 0. Then let's go for the 2. I'm going to displace on its own. I'm going to displace, or I'll give some kind of, what will be that one? I'll displace it. Now at 2, what is the slope? At 2, what is the slope? So you draw like this. So I'm going to draw a tangent here. So at 2, I drew a slope, that one. What is the slope? Negative, no? Slope is negative. So du by dr is some negative. Then what's be the force? Substitute here with sign. Substitute du by dr with sign. So what is the force acting now? Force acting at 2 will be positive. How is the displacement given? Towards left. And how the force is acting? Towards right. Then let's come for the point 3. At point 3, I'll draw a tangent. At point 3, I'll draw a tangent. What is the slope of the tangent drawn at 3? Is a positive. So at 3, du by dr is positive. So what about the force? Force is negative. How is the displacement given? Towards right. And how is the force is acting? Towards left here. So here displacement is x31, or you can say displacement is towards right. So force is towards left here. So is it 1 now stable equilibrium? Yes, no. And look at the potential, it is minimum. So therefore, what is the conformation I can make it? 1 is a stable equilibrium. What about 3? 2 and 3 are the equilibrium? What is the basic necessity condition for equilibrium? Force at 2, non-zero. Force at 3, non-zero. Force at 1 is 0. So what is the condition for equilibrium? Net force should be 0. How to check that it's a stable, unstable? I am taking help of the force. How the slope and how the slope in ux graph or ur graph, from that how do we can calculate force? The ratio between conservative force and potential is given by this basic equation. Okay, fine, this one. So about the this one. So from ux graph also, can we say about conservative, non-conservative? Yes. Say stable equilibrium, unstable equilibrium by this particular method. Okay, let me analyze few more. The ux graph. If I directly give fx graph, can you say about the nature of equilibrium? So what is the condition for equilibrium? Net force must be 0. So there are 2 points. I'm locating one and the other is 0.2. Condition for fx graph it is. Condition for equilibrium, net force should be 0. So where all equilibrium is possible. At 1 and 2, at 1 force is 0, at 2 force is also 0. Now look at that one. At 1, if I displace body towards right, what is the direction of displacement? Towards right. And how the force? F positive means the force will act towards right. F negative means the force will act towards right, towards left. Here if I displace the body, if I slightly move the body towards right, then look at the force will become positive. Positive means the force is acting towards right. So what is the convention, F positive means acting towards right. F negative means acting towards left. Okay, with this, what about what you can call one stable or unstable equilibrium? Unstable equilibrium.